Welcome to General Labs Safety Training. Presented by Bonneville Labs. Welcome to our health and safety training for laboratory work. The purpose of this training is to provide employees with general guidelines for working safely to prevent accidents and injuries. It is important that we all take responsibility for our own safety and the safety of those around us. Identifying health and safety hazards. When working in a laboratory, it is important to be aware of potential hazards. Some common hazards in a laboratory include exposure to chemicals, biological materials, and electrical equipment. Choosing appropriate health and safety measures. To protect yourself from these hazards, it is important to wear appropriate personal protective equipment such as gloves, goggles, and lab coats. Maintaining a safe laboratory environment. It is also important to keep the laboratory clean and organized to reduce the risk of accidents. This includes properly storing chemicals and materials, keeping walkways clear, and properly disposing of waste. Disposing of laboratory waste. Proper disposal of laboratory waste is essential to maintain a safe laboratory environment. Responding in case of emergency. In case of an emergency, it is important to know the location of emergency equipment and exits. We will review key elements such as safety committee responsibilities, proper attire and PPE, emergency response and equipment, electrical safety, fire prevention, hazardous material and chemical safety, waste management, incident reporting and emergency contacts. Remember to follow all safety procedures and speak with the safety committee if you have any questions. The safety committee is made up of a safety officer, department representatives, and management. As an employee, it is your responsibility to attend quarterly safety meetings, report any safety issues or concerns to the committee, and keep safety data sheet (SDS) information up to date. The safety committee is responsible for identifying and assessing hazards, implementing safety policies, and conducting regular safety inspections to ensure a safe work environment for all employees. The safety officer's main role is to implement health and safety programs in the workplace. This includes providing adequate information for employees to operate safely in the labs, understanding the hazards associated with the operations they oversee, and ensuring employees are trained and familiar with emergency procedures. They are also responsible for conducting regular safety inspections, identifying and assessing hazards, and implementing safety policies to ensure a safe work environment for all employees. As an employee, it is our responsibility to ensure the safety of ourselves and those around us. This includes monitoring our own safety, complying with safety rules and regulations, completing relevant safety trainings, reporting any unsafe conditions, and being familiar with emergency procedures. All employees are required to receive training and information to ensure they are aware of the hazards of chemicals in their work area. The training will cover the contents of the chemical hygiene plan, signs and symptoms of exposure to hazardous chemicals, and the location and availability of reference materials on hazards, such as manufacturer's safety data sheets. Training will be provided at the time of initial hire, when an employee is exposed to a new hazard or role, and on an annual refresher basis to ensure that everyone stays informed and up to date. By ensuring that all employees are properly trained, we can help to prevent accidents and injuries and maintain a safe working environment for everyone. Proper attire and personal protective equipment, PPE, is essential to maintaining a safe laboratory environment. This includes items such as gloves, safety glasses, lab coats, and other equipment appropriate to the specific hazards present in the lab. It is important to note that PPE should only be worn within the laboratory and should not be worn outside of it. Additionally, closed-toe shoes and long hair should be tied back in the laboratory to prevent accidents and injuries. In case of an emergency, it's important to know the location and proper use of emergency response and safety equipment. ABC fire extinguishers are located throughout the facility. In case of chemical spills, shower and eye wash stations are located in each laboratory and/or hallway. It's important to flush eyes continuously for 15 minutes and drench the body for 15 minutes. First aid kits are located in each laboratory. It's important to submit an incident report after using the first aid kit. Spill cleanup kits such as Biosafety Spill Cleanup Kit and Spill Kit for acids, bases, and unknown liquids are also available throughout the facility. It's important to submit an incident report after using the Spill Cleanup Kit. By familiarizing ourselves with the location and proper use of emergency response and safety equipment, we can help to ensure the safety of everyone in the facility. In the event of chemical splash to the eyes, it is important to use an eye wash station immediately. Within 10 seconds of the splash, turn on the water and place eyelids under the streams. Use your fingers to keep your eyes open, and roll your eyes to ensure that the water covers them completely. Flush your eyes for at least 15 minutes. Seek medical attention immediately after flushing your eyes. In case of an emergency, it is crucial to know the location and proper use of emergency exits, also known as means of egress. These include exit doors, corridors, aisles, and stairwells that lead to the exits. It is important to maintain main aisles inside the lab leading to exits and main corridors to be at least 48 inches wide, free of trip hazards, and other obstructions such as equipment, boxes, or supplies. All other aisles must be at least 36 inches wide. It is important to note that a means of egress is a continuous and unobstructed way of exit travel from any point in a building or structure to a public way. The safe use of hazardous chemicals is crucial in any facility. To ensure the safety of all employees and the facility, the following guidelines must be followed. All chemicals must be stored in secondary containment, or within a cabinet that is able to contain spills. Ensure that the facility is adequate for the intended use of the chemical, including an appropriate disposal method. Ensure that spill containment such as bottle carriers and secondary containment are available. Read through the SDS safety data sheet prior to ordering the chemical. Obtain prior approval from the safety officer before using the chemical if the NFPA hazard level is 3 or higher. Chemical hazards could be increased due to new procedures or changes. It is likely that the action level or exposure limit could be exceeded. For operations that are to be left unattended. For operations involving particularly hazardous substances. When there is a failure of safety equipment such as fume hood. Cleaning up spills is crucial to ensure the safety of all personnel and the facility. In the event of a large spill that is not capable of being cleaned using the spill kit, the following steps must be taken. Alert personnel in the immediate vicinity. Confine the spill, if possible, to do so without endangering personnel. Keep yourself between the emergency and an exit while attempting to confine the spill to avoid being trapped. If the emergency is inside a fume hood, close the sash, if possible. Close lab doors, if possible, to prevent the spread of vapors into adjoining rooms and corridors. For flammable liquid spills, shut off ignition sources, if possible. Avoid unplugging equipment due to possible electrical arc between receptacle and plug. Turning off breaker will work. Evacuate the emergency area. If in doubt, evacuate the building. To evacuate a building, pull the nearest fire alarm pull station on your way out. Summon aid. For emergencies that require response from the fire department, police department, or paramedics, dial 911. For other emergencies or incidents, contact your safety officer. It is important to follow these steps to ensure that the spill is contained and cleaned up as quickly and safely as possible. Chemical labeling and storage is crucial in any laboratory or facility that uses hazardous chemicals. The following guidelines must be followed to ensure the safety of all personnel and the facility. Chemicals stored in containers other than what comes from the manufacturer must be properly labeled with the chemical name, the NFPA 704 labeling system, hazards, the owner of the secondary container, and the date put into the secondary container. Properly segregate chemicals based on compatibility and ensure they are stored in secondary containers. Chemicals stored on shelves must be secured by a lip or guard and should not be stored on the floor where they can be spilled or broken. Hazardous chemicals are not to be stored above eye level. Flammable chemicals must be stored in an appropriate flammable cabinet. Corrosives should not be stored under sinks or in areas that could be damaged by corrosive effects. Hazard identification is an important part of ensuring the safety of all personnel and the facility when handling hazardous chemicals. One way to identify hazards is through the use of pictograms, as per the GHS, Globally Harmonized System of Classification and Labeling of Chemicals, regulations. Pictograms are graphic images that immediately show the user of a hazardous product what type of hazard is present. There are 9 standard pictograms used in the GHS, each representing a different type of hazard. Flame represents flammable chemicals. Flame over circle represents oxidizing chemicals. Health hazard represents chemicals that are harmful to human health. Exclamation mark represents chemicals that cause skin irritation or allergic reactions. Gas cylinder represents compressed gases. Corrosion represents chemicals that cause corrosion or damage to metal. Explosion represents chemicals that are explosive. Environment represents chemicals that are harmful to the environment. Skull and crossbones represents toxic or highly toxic chemicals. By understanding these pictograms, users can quickly and easily identify the hazards present in a chemical and take the necessary precautions to handle it safely. The NFPA, National Fire Protection Association, DIAMOND is a system used to identify the specific hazards of a material and the severity of the hazard that would occur during an emergency response. The DIAMOND is divided into 4 sections, each representing a different type of hazard. Health. This section represents the potential health hazards of the material, such as toxicity or the potential for chemical burns. The number in this section ranges from 0, minimal hazard, to 4, severe hazard. Flammability. This section represents the potential for the material to catch fire or contribute to a fire. The number in this section ranges from 0, will not burn, to 4, will rapidly vaporize at normal temperatures and pressures and will burn fiercely. Instability. This section represents the potential for the material to react or explode. The number in this section ranges from 0, stable, to 4, readily detonates. Special. This section represents any special hazards associated with the material, such as the potential for a toxic gas release or the presence of a strong oxidizer. The symbol in this section can be a letter or an asterisk. Safety data sheets, SDSs, are an important tool for handling hazardous chemicals safely. SDSs are required to be provided by the chemical manufacturer and provide important information about the hazards and safe handling of a chemical. Each SDS contains 16 sections with the following information. Hazardous waste collection and disposal is an important aspect of ensuring the safety of a facility and the environment. The following guidelines must be followed to ensure proper hazardous waste collection and disposal. Labels should include the following information: chemical contents and compositions, hazards, physical state, solid or liquid, start and end dates. No waste should be kept for longer than 180 days. Do not fill containers past 80% capacity. Store in secondary container. Contact your local hazardous waste collection agency for proper disposal instructions. Handling biological waste and sharps is crucial to ensure the safety of all personnel and the facility. The following guidelines must be followed. All biowaste must be put in properly marked biohazard bins with red bags. Waste containers must be closed when not in use. Do not autoclave your own biowaste. Contact the appropriate authority for disposal instructions. Fill containers only 80% full. Place sharps contaminated with potentially infectious materials such as needles, scalpels, razor blades, and contaminated broken glass in a sharps container with a biohazard label. Preventing electrical accidents. There are 3 types of electrical shock hazards that should be considered. Electric shock. This occurs when contact with electricity causes a current to run through the skin, muscles, or hair, and occurs when you become part of an electrical circuit. Electric shock can be fatal if the current is strong enough. Source of ignition / causing fire / explosion. This can occur from overloading extension cords or outlets, not replacing malfunctioning cords, or using damaged electrical equipment. Electrical burn. This is largely internal, caused by the electricity that flows through tissue or bone, which generates heat that causes tissue damage. To prevent electrical accidents, it is important to use safe work practices every time electrical equipment is used. Know the location and how to operate shut-off switches and/or circuit breaker panels. Use these devices to shut off equipment in the event of a fire or electrocution. Inspect wiring of equipment before each use. Replace damaged or frayed electrical cords immediately. Limit the use of extension cords. Use only for temporary operations and then only for short periods of time. Multi-plug adapters must have circuit breakers or fuses. If you receive even a mild shock from a piece of equipment, report the incident and turn it in for repair immediately. Extension cords and power strips are commonly used in households and workplaces, but it's important to be aware of the hazards associated with them and to use them safely. Here are a few safety reminders when using power strips. Use only UL-approved power strips. Do not overload power strips. Power strips typically are rated for 15 amps. UL recommends not exceeding 80% or 12 amps. Look on the power strip or extension cord to find its maximum current rating. If you need more current, get a bigger cord. Don't use the full current rating of an extension cord or power strip. Allow room for error and connect only 13A of equipment to a 15A cord. Never daisy chain extension cords by connecting them together or plug an extender into a power strip or surge suppressor. This reduces the current rating of both and increases the chance of fire. Don't leave extension cords in place for months. It is illegal to use extension cords as permanent wiring. If you need power somewhere for more than a few weeks, you need a receptacle, not an extension cord. By following these guidelines, we can minimize the risk of fire and ensure the safety of all personnel. Follow good housekeeping, keep work areas clean and organized, and minimize the storage of combustible materials such as cardboard boxes, packaging, paper, etc. Minimize flammable liquid storage. Store flammable liquids in a flammable storage cabinet and ensure that flammable liquids are stored according to the manufacturer's recommendations. Electrical cords and outlets. Do not daisy chain power strips or extension cords. If a cord is warm to touch, it is probably overloaded. Welding and open flame work is not allowed without advance authorization from your safety officer, including the use of Bunsen burners or a torch of any kind. Fume hoods are a crucial safety feature in any laboratory where chemicals are used. They help protect individuals from chemical hazards by creating a barrier between the user and the chemicals. However, for the fume hood to be effective, it must be used properly. Here are a few important guidelines for using a fume hood. Do not exceed the working sash height indicated by the yellow arrows. This can affect the hood's ability to capture fumes and protect you from chemical hazards. Do not vent chemicals inside the hood. All waste containers must be sealed when not in use to prevent any accidental releases of chemicals. Do not store items inside the fume hood. This can affect the airflow and reduce the effectiveness of the hood. Make sure the certification of the hood is up to date. If it is not, do not use the hood. The fan blower should remain on at all times, with the sashes closed when the hood is not in use. Work at least 6 inches inside the hood to improve the capture of fumes and airflow. By following these guidelines, you can help ensure that your fume hood is working correctly and protecting you from chemical hazards. The following guidelines must be followed to ensure proper incident reporting. Immediately report work-related injuries, illnesses, incidents, and/or near misses that are a result of employment to your safety officer and your manager, including those which occur off-site or on company-related travel. Subsequently, the safety officer is to notify the operations team of the name of the employees affected and the nature of the injury. Manager and safety officers are required to complete an incident report for any injuries, illnesses, incidents, and/or near misses that are related to job activity within 24 hours and submit it to the site manager and operations team. Accurately and thoroughly document the incident, including what happened, when, where, and who was involved, and any contributing factors. Follow up on the incident to ensure that all necessary actions have been taken to prevent similar incidents in the future. Thank you for taking this training. To complete the training and ensure you receive credit, please complete the quiz.